Hello everyone, it's Kevin, and welcome back to another video. This is a new series of videos which are meant to be a bit more informal, a bit less polished, and less edited, and they're meant to be longer form workshops. So we'll do a deep dive on something that we already have typically on the doc site, but perhaps we haven't yet covered it in video form. Now, with this new video series, we are looking for your feedback. So I'd love to hear in the comments section or anything else, what you liked, what you didn't like, thoughts for next workshops, what you want to see, anything like that, because I do want to tailor it exactly to what you're looking for. Okay, so without further ado, let's go ahead and dive into the workshop. So just briefly, I have a few slides here. Most of this is going to be hands-on, and we're going to be talking about Ethers. And Ethers is one of the most popular Ethereum JavaScript libraries. And because Moonbeam is fully Ethereum compatible, Ethers naturally works with Moonbeam. So we've covered it on our doc site. We've covered it very briefly in Moonbuilders Academy. I think we have a video or two about it. But today we're going to go a bit more in depth. We're also going to talk about some of the differences between Ethers v5 and v6. So all the information that we have on the doc site is the latest version, so that's currently v6. And we'll talk about some of the differences between v5 and v6 so that you can be prepared and all up to date. So let's just take a step back, right? When you hear people typically say that you interact with the blockchain, right? What does that mean, interact with the blockchain? Typically it means that you have a wallet or you have a front-end DApp and you're using something like MetaMask, and MetaMask will send a request which will ultimately go to a blockchain node. That's right, it'll go to a blockchain node at the end of the day. You may be using a public RPC endpoint. That public endpoint may be load balanced. There may actually be, many tens of nodes that are behind that load balanced endpoint. But at the end of the day, your request is actually going to one. And it's going to one that's synced up. And it has to be synced up because if a node isn't fully synced to the current state of the chain, it's almost worthless, right? If you could say, hey, I know the state of the chain 3 minutes ago or 30 minutes ago, that is exponentially less valuable than a node that says, I know the current state of the blockchain. So there are many different options that you have for connecting to a blockchain, right? You can use a public endpoint. That's perhaps the fastest. And we have a bunch of ones listed here on our doc site. If you just go to builders and then you go to network endpoints, you can see all of the public endpoints. And we might use this today. That's perhaps the fastest, but it's not recommended for production use or for extended development use. For that, we recommend that you get yourself set up with a personal endpoint. This can be thought of as an API key. So we have two examples here, Blast API and one RPC, but there are many others here on the Moonbeam doc site that are documented. And they would be very happy to give you your own personal API key or endpoint that you can use, and they're very generous with limitations. So you can do many, many thousands of requests per day without running into any sort of limit. And the third option might be to run your own node. And I highly recommend everybody at some point run their own node, even if you don't need it forever, but just for fun, get it set up, learn the process. That is quite fun. So I do recommend that. When you're running your own node, though, you might have it hosted on Amazon or Hetzner or DigitalOcean or many of the other providers. Or you might run it in your own house. That's perfectly fine too. You might have your own machine. But you are responsible for your own maintenance of that node. So keeping the operating system patched, keeping the client updated so that it's always running the latest version of the Moonbeam client. And so there's a little bit of work that you need to do there. The fourth option, and perhaps the most expensive, is if you have a service such as Blast or OneRPC run a dedicated node for you. Now, what's the difference between a dedicated node and your own personal endpoint? Well, with your own personal endpoint, you're still sharing a node at the end of the day. You're hitting a node that's being used by many other people. And perhaps you have a special case where you're saying, nope, I want my own personal endpoint where nobody else is using the node that's hitting. And this would naturally be the most expensive option. So let's give a quick example of interacting with the Moonbeam JSON-RPC, also known as the Ethereum JSON-RPC. let me clear this out. Okay. So this is an example just using a simple curl command here, and we are using the ETH get balance method. It's very simple. It takes just two parameters. One is the address that you're looking for, and the next is a block tag. So this could be the latest block. This could be a finalized block, or a couple others. You can also give it a particular block if you want to balance as of a certain period in time. So let's go ahead and run that. And okay, we get back a result, but this is not all that helpful to the untrained eye. We get back a hexadecimal value. So let's first go ahead and convert that from hexadecimal to decimal. And we'll get back a value that's quite large. And that's because this is in Way. So we need to convert this from Way into something that's more readable to us. And Ether is the exact same unit as Dev and the same unit as Moonriver and Glimmer. So we can see here my account has a balance of 96.09 Dev tokens. So as a quick example, I also wanted to demonstrate that for the Ethers workshop and for pretty much any of the workshops that we do, you may choose to run your own local dev node, or you may also use Moonbase Alpha. I'm going to be using Moonbase Alpha. I think that fits well with the demo, but you can use any option that you'd like. And when you're running a local dev node, that state is not shared. So when you fire up the node, it starts and it resets state each time that it fires up. And that state is only on your machine. Nobody else knows that state or shares that. Whereas with Moonbase Alpha, it is a shared state, and there are many nodes that are replicating the status of the network. And you can deploy a contract, you can come back weeks later and then interact with that same contract, which is likely not the case with the local dev node unless you kept the dev node running on your machine for that whole period of time. And lastly, just a quick little bit of Ether's nomenclature. So Ethers can provide you with tools based on what you're looking to do. If you're looking to just read from the blockchain, you can use an Ethers provider for that. And my example here is, let's say you're walking down the street and you see a beautiful Pagani Huayra. You can look at it, you can check out the tires. If it's convertible, maybe you can look in the inside of the car and see the leather and the steering wheel. But you can't do anything with the car. If you wanted to move it, if you wanted to change its position, you would need to have the key. And the key is actually down there. It's actually modeled to look just like the car. And so that's what you would use an Ethers signer for, is if you want to change the state of the chain. You want to call a contract, you want to submit a transaction, send funds from one account to the other. Anything like that requires a signer. And the setup of using a provider and a signer is actually quite similar, but a signer is going to require a private key or a seed. And it's also going to need that because it needs to fund whatever transaction is taking place. So like I mentioned earlier, we're going to be following along pretty much exactly according to these steps here on the Moonbeam doc site. So go ahead and check that out. You can also scan this QR code. And without further ado, let's go ahead and jump right into it. So first thing that I will do here is I need to install Ethers and the Solidity compiler. And I already have a folder set up here. So if you don't have a folder structure, go ahead and set that up. And I also want to install a specific version of Ethers. I want to install 6.2.2, as well as the Solidity compiler of 0.8.0. Cool, so that's installed. And to verify that it's installed and the correct version is installed, I can run npm list -- depth of 0. And you'll see here I have 6.2.2, and I have a couple of other packages here as well. So everything's looking good there. And we're going to start by creating a read method, which is just going to check out the state of the chain, and it's going to report back some balances to us. And we're going to rely on this a couple different times. So this is an important script that we need to set up. So let's call it touchbalances.js. And go ahead and open up your preferred text editor. Cool. And the first thing that we'll be doing in most of these scripts is we're going to be setting up our provider or our signer. Now, in this case, we're just reading from the chain, so a provider is perfect. And on the Moonbeam docs site, we have templates for each network, for Moonbeam, Moonriver, Moonbase Alpha, and a local Moonbeam node. And so you can go ahead and copy and paste this template, and it already has the pre-filled public RPC endpoint. So we can use that, and that will be just fine. We also specify the chain ID for Moonbase Alpha, which is 1287. You'll also notice that we require ethers, and we have specifically configured here our provider RPC constant to be able to support multiple different networks. So if you'd like, you can include Moonbeam, you can include Moonriver, and you can include many different networks, and that makes it very easy to bounce between them if you'd like. And then when you're creating your provider down here, you would just specify the different network for the chain ID and the name as well. So we only need Moonbase Alpha today, but I just thought that was important to mention. So in our balances script, we're going to have a couple different addresses that we're going to look at. So we're going to look at an address from and an address to. And I'm going to go ahead and create two different addresses here. You can use Moonkey. This is a great tool to create test accounts with. You can also just create one any other way that you'd prefer. And the two accounts that I'm creating, these are going to be, they're going to have their private keys exposed. And these are development only accounts, so you should not use them with any real funds. And of course, it's important to follow best practices for storage of private keys. Today, we're going to be simplifying the steps a bit, and we may be storing private keys directly in the files that we're working with. Now, that's of course not recommended. One option instead is to store them in a secrets.json file. You can make it a hidden file if you'd like, and then you can add that to your git ignore so that you don't accidentally commit it to a repo. My thoughts on this include also that you should create a new development account for testing purposes only. And so even if you do commit this by accident, it's not a big deal because you only have dev tokens there. So just a few thoughts there. Okay, so I've created my two accounts. I've got my from account and I've got my to account. And let's go ahead and save this. And let's go ahead and create a balances function. It's going to be an async function. And all we're going to do here is create a constant for balance of the from address. And we're going to say ethers.formatEther. And this is the difference between ethers v6 and v5. So in v6, you can just say ethers.formatEther, whereas in v5, you previously had to say ethers.utils.formatEther. So just a quick shortcut that's quite helpful. And we are going to wait for our provider to get the balance of the from account. And when we say await here, we want to make sure that we get the balance before we store it in this variable. So let me expand it just a bit. We're going to do the same thing for the balance of the to account. And let's put an equal sign in here. And again, ethers is helping us with this format ether. Otherwise, we'd be getting it back in a less convenient fashion, similar to how I showed on the curl command. So that's just one thing that ethers does. Ethers does much more, but typically you don't want to be dealing with the minutia of converting different amounts away and things like that. So ethers helps with that. Okay, provider.getBalance and address 2. Close this up and let's log it out to the console. And feel free to copy and paste this directly from the doc site if you'd like. And let's close this up. And lastly, we just want to call our balances function. So let's give this a shot. There may be an error. If there is, we'll get it sorted out. zoom in just a bit. Cool. And we'll run it with node balances.js. Cool. So the balances of both these counts are empty, and actually instead of ETH, we should say dev. So let's correct that. Cool. And let's go ahead and get funds from the Moonbase Alpha faucet. And we can get that at faucet. Let's see. Actually, we can get it at apps.moonbeam.network/moonbase-alpha/faucet. And you only need to fund one account, so go ahead and copy the address of one account. Cool. So we're all set there. Now let's create a send transaction script, which will just send some funds from one account to another. And to do that, let's go ahead and create our new transaction.js file. We'll go ahead and open it up. And similar to how we structured our balances.js file, we are going to need to provide all of this same information, all of this provider logic. Even though we are going to be providing a signer, we still need to specify the network, the RPC URL, all of that. So make sure you have all that. Then we're going to define our from account here. And we are going to be providing a private key here. Again, you should not, this is only for demonstration purposes. Cool. And let's just close this up. We'll also have our address too. Call it account 2. And let's go ahead and copy and paste that. And we're going to create a wallet, and we can create a wallet with the instructions here of let wallet equals new ethers.wallet with a capital account from dot private key and our provider. So we're specifying the same provider that we defined up here. And let's create a send function. So it's going to be async as usual. It's always helpful to sometimes include a debug line to mention what you're doing. In this case, we can mention exactly what we're trying to do here. And let's go ahead and create our transaction object. So we want to send funds to the address 2. And we want to specify a value of ethers.parseEther of 1 for 1 dev. And that'll do it for our transaction here. Now notice that we haven't set a variable for our address from. We just have a private key. And this is because ethers can deduce what the from address is when you provide the private key. Cool. So that looks good. But the next thing that we need to do is we've created this transaction, but we haven't done anything with it. So we actually need to sign and send it. So let's create a transaction receipt here, and we will await for the wallet that we've created called wallet to send the transaction, which we've named transaction. And we're going to wait. And if everything works, we're going to log out a message that the transaction was successful with the hash that is stored in our receipt. Oops. Need to clean this up a little bit. There we go. Cool. And let's close this up. And lastly, we just need to call the send function. So make sure that your account that you're sending from is funded with sufficient funds. If you've used the faucet, you'll have 1.1, which is enough to cover the send amount and enough to cover the gas fee. So that should do it for this. Let's go ahead and run it. Oh, I think we specified address to rather than account to. So let's fix that. To make sure that we're consistent. Cool. Oops, account to. There we go. And our transaction was successful. Now let's go ahead and run balances again just to see the change in balances. And this is exactly what we expected. Perfect. Now let's get a bit more advanced and let's actually deploy a contract with Ethers. And in order to deploy a contract, we need to have a contract first. So let's go ahead and create one. We're going to create one that you've probably seen before. This is a very simple contract and it's only going to do a couple different things. So we should be able to write it up in no time. The first thing we'll do is we'll define a license identifier. Remix will complain. You probably won't have much trouble with Ethers, but it's just good practice. So let's have that. Let's also have our pragma solidity statement of 0.8.0. And let's create our incrementer contract. So incrementer is going to store a single UN256 that's public, and it's going to be called number. And the constructor is going to require that you define an initial number when you're deploying the contract, and that'll be the contract's initial value. So let's just set number is equal to initial number. Cool. That'll do that for the constructor. Then let's have an increment function, which is also going to take a UN256 of whatever value you want, and it will be public. And all we're going to do is take the stored number and we're going to add the value to it. So easy enough. And lastly, let's also have a reset function. This is going to take no parameters. It's also going to be public. And all it's going to do is take our number back to 0. And that's it for our incrementer contract. And the next thing that we need to do is we need to write a quick script to be able to compile our Solidity file. And this will be a little bit different, but let's go ahead and compile or create our compile script. So we'll call it compile.js. Let's go ahead and open it up. And the first thing we're going to do is we're going to import file system thanks to Node. So let's require file system. We are also going to require the Solidity compiler. Very important. And we are going to define our source as filesystem.readFile sync. And it's going to be incrementer.sol is the name of our file. If you've named yours differently, be sure to specify that. Then the type of encoding, which is going to be UTF-8. That's written as just UTF-8, no dashes, no nothing. Cool. And let's create our input object. So we'll call it input. And we're going to be defining a few different things here. First thing, we're going to say that the language is Solidity. Oops. Solidity, comma. The sources that we're going to be pulling from are going to be a file named incrementer.sol. Let's open this up. And what type of content is it? This is going to be our source content. Add the commas here that we need. And we also have some settings to define here. So in settings, we're going to be specifying what we want as part of our output. And there's a couple different things you can do here. You can specify exactly what you'd like in terms of output, or you can say, give us everything. Later, we'll pick and choose from what we want. And so that's what we're going to be doing here. We're going to be specifying a bunch of wildcard characters, essentially saying, to the Solidity compiler, just give us everything, and we'll choose later on exactly what we'd like. So we're going to specify our output selection, and we are going to include our first wildcard character, which is going to be followed by an open bracket here. And that's going to be followed by another wildcard character and a colon, brackets, and another wildcard character and a comma, and that will be it. So make sure you include commas for all these. We can close out here, and let's actually compile the contract. So we're going to create a temporary file here, and we're going to say json.parse solidity compiler.compile, and we're going to take the string, a stringified version of our input file. And we're also going to have a contract file, and we're going to take our temporary file dot contracts of incrementer.sol, and we're specifying not just incrementer.sol, but also the name of the contract here, because they could be different. They're the same in this case, but we need to specify both. And we typically like to have just one Solidity contract per Solidity file, but some people do it differently. So that's why we have to specify both. And lastly, let's define our module.exports as our contract file, so that later we can call upon module.exports, and that's when we'll be asking for the exact output that we want. So cool. Let's go ahead and give this a shot. So we'll say node compile.js. Cool, no errors, so that's looking good. Now we need to write a quick script to deploy our contract. So let's go ahead and do that. Let's open it up. We're going to have to import the contract file here. And we're going to require /compile. We're also going to include all of the provider logic that we've included in prior files. And you can include also the private key as well. Because we're going to be deploying from a particular account, we can deploy from the from account. That's perfectly fine. And now finally comes the time to ask for the output that we want. So we're going to ask for the bytecode of the contract. So we're going to say contract file.evm.bytecode.object. And we're also going to ask for the ABI, which can be accessed with simple contract file.abi. Let's also create a wallet. You can copy and paste this if you want, or we can just write it again. We're going to say new ethers.wallet with a cap, account from, .private key, and we're also going to specify the provider. If you've named your provider differently, make sure that you also provide the correct name down here. Okay, so we got our wallet, we got our signer. I'm using those terms interchangeably here. Next, we are going to create an instance of our incrementer contract. And to do so, we're going to be relying upon a contract factory. And this is important because creating a new contract is a special type of transaction. Typically, we always define a to address. So if we're sending funds to an account, we have the destination account as the to address. If we're interacting with an existing contract, we have that contract address as our to address. But in this case, we don't have a contract deployed yet. So it's a special type of transaction that's relying upon a contract factory, and then it's defining this to account as actually nil to begin with. And that lets the chain know that this is a special contract deployment. So let's go ahead and create our incrementer contract instance. So we're going to say new ethers.contract factory. And it's going to take in a couple different parameters. It's going to take the ABI, the bytecode, and then also a wallet. And the wallet that will be doing the deploying. So let's create a deploy function. And let's call it deploy. It's going to be async. Good practice. we can always log out what we're doing. And then let's go ahead and define our transaction. So we're going to wait for incrementer to deploy, and we're going to specify an initial value. You can specify whatever you'd like here. Okay, and next we want to work with our transaction receipt. So let's wait for our contract's deployment transaction. And very important here, you do want to log out the address of the contract that's just been deployed. And this is because we will need this for the next step. Cool, let's close this up. And let's actually call deploy. So go ahead and save this. And let's go ahead and run it. Cool, so we're all set there. And if we go ahead and copy and paste our contract address, we should be able to look this up on moonbase.moonscan. Cool, and there it is. And let's go ahead and actually interact with our contract. So we'll create two scripts here. One will be a read one, and the other one will be a one that actually changes the value of our contract. We'll actually create two write ones. We'll create an increment one, and then we'll create a reset one. But let's start with a read one. So we'll call it get.js. Because it's we're just reading data, we're going to need to copy and paste all of the provider logic that we've used in the past. And we're also going to need to import the contract ABI. And this is important because our contract is not verified. So nobody knows what methods are available for us to interact with. So we do need to make sure that we import the ABI. So we can do that by saying import, and we can do it at the top just for clarity here. Let's import the ABI. /compile. And we also want to provide the address of our contract here. So go ahead and grab that from the terminal. Or you can copy and paste it from Moonscan, that's fine too. Let's head down here and let's create an instance of our contract. So we're going to say new ethers.contract. Notice that we're not saying contract factory. Contract is already deployed. So let's say contract address, ABI, and provider. So provider here, we already know about that. ABI we need because we need to define what methods we can actually call and interact with. And then contract address, of course, because Ethers needs to know where's the contract deployed. Let's create our get function. So it'll be async, and it's always good to have a console.log statement, so we can include that. And let's create a constant called data, which is going to just call incrementer.number. Now, for astute eyes, you may notice we didn't have any sort of read function called getNumber or anything like that. So if we head back to incrementer.sol, all we have is an increment function and a reset function. So where the heck is this number function coming from? Well, Solidity will actually generate for any public variable that you have. Solidity will go ahead and automatically generate a getter function for you. So you can just say number with an open close parentheses. So if you have another variable and it's called number2 or number 5 or whatever, you can do that same step. So we are all set here. And lastly, let's just log out the that number so we can see it. Let's close this up and let's call get. And yeah, let's give it a shot. Cool, and the number stored is 5, but not for long because we're going to change that. So let's create a quick script to change that. And let's call it increment.js. And we're going to be copying and pasting a decent amount of prior content here. Actually, just about everything up to here. Let's start with just that. We also need to have our private key. So let's go ahead and copy that. And we have our contract address. And let's also create a value here. So what value would you like to increment the contract by? It could be 10, 20, whatever you want. Let's create our wallet. So you can copy and paste this, or we can just rewrite it. So ethers.wallet account from .private key, and we're also using the typical provider that we've defined up here. Let's create a contract instance of incrementer. So that's going to be new ethers.contract. Again, we are just interacting with a contract that's already deployed, so we're just using contract. We're not using contract factory here. And let's create our increment function. So it's going to be async as usual. And if we'd like, we can log out what we're doing. Always a good idea for clarity. Then let's create our transaction here. So I'm going to say create receipt, increment, and we need to provide that value, which is going to be 10 in this case, but you can make it whatever you want. Now let's wait for the transaction receipt. And if it is successful, then we want to log out to the console that it was. Create receipt.hash. Let's make sure our formatting is all good here. Cool. Close this up, and then let's call increment. Save it. And let's run. Cool, so that was successful. And just as a check, let's run get.js one more time and let's see what we get. Cool, exactly what we expected. So we are just about done, but there's one more quick script that we can write, and that is our reset script. So let's go ahead and do that really quickly. We'll call it reset.js. It's gonna look similar to increment with just a few differences. So let's copy and paste all of the information here up to and including wallet. And actually, let's include the incrementer as well. Let's include that. We can delete the value here. We don't need that for this one. And let's go ahead and create our reset function. It's going to be async as usual. We can log out what we're doing. That's always a good idea. And let's create our transaction. So as usual, create a receipt. And we're going to call incrementer.reset. Takes no parameters. And then we want to wait for the receipt. And if it was successful, let's log out with the transaction hash. Cool. Just close this up and let's run reset. Save it. And we'll run reset.js. Cool, so that appears to be successful. Let's go ahead and run get.js one more time, and we should see a 0 here. Perfect. So I hope this has been a helpful introduction to Ethers. Please leave a comment. Let me know what you'd like to see next. what topics would you like to go more in depth. Maybe we've covered them on the doc site, maybe we haven't. Let me know. And thank you so much for watching, and I look forward to seeing you in the next video.